Number 12. Number 12 shows the last intermediate value theorem problem between 10 and 12. And we're going to look to see, again, if the theorem holds, what is that C? And if the theorem does not hold, give the reason why. We're going to go ahead and sketch the graph. So this is a rational function. The parent function is 1 over x with a vertical shift 2 units to the right. So if I quickly did a vertical asymptote change 2 units to the right, you're going to see something like about here. Okay, so let's go ahead and put 1, 2. There was no change on the horizontal asymptote. That stayed the same, and it would stay here. So my graph looks like the following. Looks like this, and it looks like that. Notice how we're only looking at, we're looking at this y value of 5, 6, which is about a little bit under 1. So if that's 1, this is 1, we can say that it's going to be somewhere around here is my k equals, or y equals 5, 6 value, the horizontal line. Now we are looking at our interval between 3 and 5, so it's probably around here to here. And we're going to go ahead and now go through the steps to see if the theorem holds, give the C value. If it does not hold, give the reason why. Rule number, or the first part. Is the function continuous on 3 to 5? Obviously it is. It's continuous everywhere except at 2, by just what we know of the domain of the parent function of 1 over x. So this is going to be f of x is continuous on 3 to 5. If it wasn't, we would show right there, right at the very beginning, theorem does not hold, done. You're done. Alright, rule number 2. F of a does not equal f of b. We must show that f of a, the y value from a, does not equal the y value from b. So what is the y value from a? Well, if I put 3, which is my a value here, I'm going to get 1 as an answer. And that is not equal to 1/3, which is my y output that I would get if I put 5 in to the equation. So far so good. I can keep going. The k that they've given us is 5, 6. Here's the question that I need to ask myself before I work and move forward. The y value of 1, the y value of 1/3, does this 5, 6 occur somewhere in between? Yes, in fact, it does. Because it does, and this is a continuous function, we can go ahead and go to the third one. The theorem is still holding. We'll say let k equal 5, 6, which f of c is equal to 5, 6. And we're basically going to solve for c. Let's recopy my original equation. 1 over c, because we're using c's, is equal to f of c. This right here is just going to be replaced where you see f of c, so that we get 5, 6 is equal to 1 over c minus 2. If I cross multiply and divide, I can do that here. I'll get 5c minus 10, because I distribute that. It's like 5 times c minus 2 is equal to 6. Add that over, we get 5c is equal to 16. Therefore, c is equal to 16 fifths, which is about 3 1/5, or 3.2. Is 3.2 in between 3 and 5? It obviously is. And it will hold, because everything that we did as far as check 1, check 2, and making sure that our k value was in between these two given output y values, of course it's going to yield an answer by intermediate value theorem that exists between 3 and 5. And that is that 3.2 or 16 fifths. Therefore, theorem holds, and there exists a c value which is equal to 16 fifths, which is in between 3 and 5. Or you can say on the interval 3 to 5. And you're done.